let us see about drift and diffusion current and also forward and reverse bias characteristics. Here, while we are seeing the drift and diffusion current, the flow of charges current through the semiconductor material are of two types, that is drift and diffusion current. That is, first one is drift current. That is, when an electric field is applied across the semiconductor material, the charge carriers attain a certain drift velocity Vd, which is equal to the product of the mobility of the charge carriers and the applied electric field E. Therefore, the drift velocity Vd equal to mobility of the charge carriers into applied electric field intensity. In this, the hole moves towards the negative terminal of the battery and the electrons moves towards the positive terminal of the battery. This combined effect of movement of the charge carriers constitute a current that is said to be the drift current. Thus, the drift current is defined as the flow of electric current due to the motion of the charge carriers under the influence of the external electric field. Here, that is the drift density, current density due to the free electrons is given by this equation, and the drift current density due to the holes is given by this equation, where n is the number of free electrons per cubic meter and p is the number of holes per cubic centimeter, and mu n is the mobility of electrons in centimeter square by Vs, and the mu p, it is the mobility of holes in centimeter square by Vs, and E is the applied electric field intensity in V by M, and Q is the charge of electrons, that is equal to 1.6 into 10 the power minus 19 coulomb. Then we can Px is the concentration in semiconductor bar varies from the higher lower value to the low value along the x-axis and is constant in y and is a direction. Therefore, as shown in figure, that is dp by dx is the negative and the minus sign in equation is needed in order to that jp has positive sign in the positive direction. Therefore, it is that is the diffusion current due to free electrons is given by this equation, where dN by dx, that is the concentration gradient for electrons, and dp by dx is the concentration gradient for holes, and dN and dp are the diffusion coefficient for electrons and holes. And total current, that is the total current the semiconductor, is the sum of both the drift and diffusion current is given by this equation. Similarly, the total current density for the n-type semiconductor is given by this equation. Next one is the forward bias condition. When positive terminal of the battery is connected to the n-type and the negative terminal to p-type, then the p-n junction is said to be the forward bias condition. Here, in this, that is when the applied potential in external battery acts in opposition to the internal positive barriers, which distributes the equilibrium. And as soon as the equilibrium is distributed by the application of the external field, the Fermi level is no longer continuous across the junction. Under the forward bias condition, the applied positive potential replies the holes in p-type region so that the holes move towards the junction, and the applied positive potential replies the holes in n-type region so that the electrons move towards the junction. And when the applied potential is more than the internal barrier potential, the depletion region and the internal potential barrier disappears. Here, this is the VA characteristics of this diode. Next one is the reverse bias condition. When the negative terminal of the battery is connected to the p-type and the positive terminal is to the n-type, then p-n junction is said to be the forward, that is the forward bias, and the holes from the majority carriers of the p-type moves towards the negative region of the battery, and holes which from the majority carriers of the n-type are attracted towards the positive side of the battery, and hence the width of the depletion region, which is depleted of mobile charge carriers, increases. Thus, the electric field produced by the applied reverse bias is the same direction as the electric field of the potential barrier. Hence, the resultant potential barrier is increased which prevents the flow of majority carriers in both the direction. Therefore, the depletion width is proportional to under reverse bias condition. And this is the VA characteristics. Thank you.